All right, welcome back. So day two, we're still talking about parabolas and a geometric conic section definition here. And what we're going to work with now is we're going to talk about standard form and transformations. Now, when we talk about transformations, we're talking about these parabolas and their key features, the focus, directrix, and vertex, being shifted left, right, up, and down via those H and K transformations. Standard form. Now, what happens with standard form is we're going to get something that looks like this. Y squared plus 2y plus 12x plus 25 equals 0. A lot of times the 25 will be over here, but most of the time it's set equal to 0. This is considered our standard form of this conic, okay? And what happens here is we're going to have to do some factoring and some other stuff. We're going to change the way this thing looks so that we can find the value of p. Now, because this is a y squared, we know some stuff about it. We know it's going to be y squared equals 4px. We also know it's going to open left or right depending on how p is, whether it's positive or negative. But we're a long ways away from getting it to that spot because we've got some extra numbers in here that don't quite make sense and plus signs, and I'm going to show you how to deal with that right now. So to deal with this, first off, let's get the stuff on either side of the equal sign where we know it's going to need to go. So notice that stuff with x needs to be over here on the right side. So let's do that first. We're going to move this stuff over here. So that's going to be negative 12x minus 25 when we move it over here. And this is going to stay y squared plus 2y. Now, what we need is, and there's going to be a transformation listed in this, okay? Because what's going to happen is this is going to look like this. Okay? There's going to be an H and a K transformation. The K, if we remember from all the times we defined it, moves the graph up and down. The H is what moves this thing left and right. That's a 4. I apologize for the messiness there. Okay? Now, what that means is we're going to have to take this thing and we're going to have to do some factoring because there's no squared in this yet, okay? And this needs a nice factoring as well. Now, one rule of thumb here, you don't factor this other side without the square until you've gotten the left side over here with the term with the square the way you want it. Because what we're going to have to do with this is we're going to have to complete the square, okay? So when we complete the square, if you remember back to when we learned this in Math 2, we do this with a box and an extra box. Okay, because what happens is we want this to factor. We want this to factor a special way. We want the number that we're going to get right here to be the same thing. And right now that's not going to work because we don't have a third term over here. We get 0. There's no way we're going to get 0 right now. Now to make this work, first off we take this y squared. This y squared has to be here. That's how way that'll factor into y and y. Now we want this to factor special. So what we're going to do is we're going to split this in half. So what's half of 2? Half of 2 is 1 and 1. Okay, we're always going to take this term right here and we're going to split it in half because what we're doing is we're going to pick our own value here to make this factor the way that we want to. And the way that we find the number that goes here is we take this 1 and this 1, and we multiply these two things together. So 1 times 1 is positive 1. Now what will happen is now this factors and gives you positive 1 here because these were plus, and this factors and gives you positive 1 here. And what we see is this is now y plus 1 times y plus 1, which gives us the y plus 1 squared that we wanted for this. But I can't just arbitrarily add a number over here and not do anything about it because that changes the actual equation itself. It means I have to balance it out, and that's where this extra box comes in. Whatever I put down here in this box, I have to counteract it right here. So I added 1 there, so I need a minus 1 here. So that's going to be minus 1. That's called completing the square. We're getting this special factor when we make these two things right here the same, we get the same number here, so we get the same factoring. So we get this same term squared. And we've got to counteract it by balancing it with whatever we needed to put here to make this factoring work. We've got to take away here. Now, we didn't change anything about the right side of this equation here. So we get 12x minus 25, okay? The reason I told you not to factor this until you were done is this number that we had left over can't be over here. This has to go over here with its other side with this constant. So we're going to need to add that over. So we're going to get y plus 1 squared. And when we add 1, we're going to get negative 12x, and now it's minus 24. And for the ones that we're going to definitely start with, you're going to get something nice that factors out of this, because notice we need to factor this out to find out what 4p is, because that's the important part of this about finding this stuff. We get y plus 1 squared equals, now those both have a negative 12 in common. So we get x, and we're going to get what? Plus 2. Now what this tells me, and we're going to go on the other slide and work with this a little bit more because we're about running out of room. These two things are transformations on this. This is equivalent to the graph y squared equals negative 12x, but it's been shifted. This tells me it's gone to the left by 2. This tells me it's gone down by 2. We have to take those things with these points and apply that to the equation that we have up here, okay? So what we're going to do is I'm going to write both these things on the next slide, and we're going to find our points like we did yesterday using y squared equals negative 12x. And then we're going to shift around those points and see what happens. So let's write all this down on another slide. So we figured out that this turned into, what was it? Y plus 1 squared equals negative 12, and this is x plus 2. Now what I'm going to do is I'm going to forget about those for a second, okay? I'm only going to find the p so I can find the shift, because what we're saying is this is the same graph as y squared equals negative 12 times x, but because of the two transformations we're forgetting about until the end, we've got to move it down by 1, and we have to move it left 2. Now down is going to affect our y's. And what's it going to do to our y's? It's going to take away 1. So whatever we have for those coordinates, we can minus 1 from the y's. Left, that's going to affect the x's, and we can minus 2 from those. So we still use this number 12 to figure out what p is, and then we'll change everything. So if 4p is negative 12, that means p is negative 3. So that would mean, now remember, if we're working over here, our vertex always starts at 0, 0. Now because this is a y squared and p was negative, that means this thing should open to the left, right? This way. So that means our focus is going to be a p0, and our directrix out here is going to be an x equals negative p. So our focus is going to be negative 3, 0, and see, since p was negative, that makes that come out the way that we thought. Directrix is going to be negative 3, which is x equals positive 3. So now, to find where these points actually are, we need to apply these shifts. So I'm going to highlight these in green. Let's use yellow this time. These are what we're going to do right here. So we're going to take all the x values for these, both the x values for these 2 points, and we're going to minus 2. So 0 minus 2 is negative 2, and negative 3 minus 2 is negative 5. Now we're going to apply the shift for the y. We're going to minus 1. 0 minus 1 is negative 1. And 0 minus 1 is, again, negative 1. Now, we got to think about this asymptote, because only one of these things is going to affect the asymptote. If we move it up and down, it's not going to change its position, because it goes up and down forever. So that's not going to change anything about it. So the up and down, or the y change, isn't going to affect this thing. The x change, which moves us left or right, is going to affect it, because it's going to change its actual position on the axis. So the only thing that affects this one, because it's an x equals, is the x change. So we've got to take this number and minus 2, and that tells me that this should be at x equals 1. So a quick sketch would have us, let's graph our points first. 2, 3, 4, 5. So that's negative 5. And we're going to go down here and then -1. So that's -5, -1. That's our focus. And -2, -1. There's our vertex. Our directrix is at y equals 1. So it is a line over here. And it's going to be right here. We get it in the right spot. We can put some arrow points on the end of that thing and label it, because labels for sketches are really important, because that's the way we can call our sketches. We can label it. So this is at x equals 0. Now we know the parabola is going to go through the vertex down here, and it's going to curve this way, like this. And since we have the actual numbers labeled here, I'm going to leave this. That's our vertex. That's our focus. And we can just kind of put little arrows. There it is. And this is what we had nice and drawn out. We see we matched up and we got that there. Let's try another one. So this is a y squared again. Now that means it's going to open left or right depending on whether the p is positive or negative. So we get y squared. Let me change out a red here. So we're going to get y squared minus 6y equals, now we're going to move these to the other side, they're both going to become negative, -8x minus 25. So let's go through and see what happens. We need to complete the square with this part. So the y squared goes in here and gets split up evenly to y and y. We're going to take this thing and split it in half. So half of -6 is -3. And that will make, now we got to figure out the number here to make the factoring work out. So -3 times -3 is +9. So these have a -3 in common. These have a -3 because that's the only way I can get that +9. But I can't just add that 9 without counteracting it with a negative right here. So that means I get y minus 3 squared minus 9, and I have not changed the other side yet, 25. And that means this needs to go to the other side, so that means it's going to add. So we get y minus 3 squared, and -8x doesn't change, 25 plus 9. That's going to give me 16, and there we get that common factor that I said we should have. Y minus 3 squared, we're going to factor out the -8, and we get x plus 2. So now we have our transformations here. And do note that this is a little bit different because both x and y both appear backwards in this thing. So this is actually going to move us up 3. This is going to move us left again by 2. So we want to pull our points out of y squared equals -8x and then transform them. And for this one it's pretty easy because this is 4p. So if that's 4p, 4p is -8, that means p is -2. Now we knew it was left or right, and we got a negative again, meaning that this, since p is negative, we've just figured out that this thing's going to open this way. And that's important because it means that our focus is going to be a p0, and our directrix again is going to be a x equals -p. So let's list those and apply the transformations, and then we'll look at the graph. So we know that our vertex is going to start at 0, 0 for this one. The focus for this one is going to be -2, 0, because it's whatever value we got for p and 0. And the directrix is an x equals, and it's x equals -p. -2 is +2. Now let's apply our transformations here. So we're going to do the x first. So x tells me left 2. So that means I'm going to take the x values and I'm going to -2 from them. So both these x values -2, that's -2 and that's -4. Y's go up, so that means the y's this time are going to go +3. So 0 plus 3 takes me to 3. 0 plus 3 again takes me to 3. Since this is an x equals, this affects it, and nothing else. So this is an x equals 2 minus 2 is 0. So it's an x equals 0, which actually means that we're going to be on the y-axis. So these are the points of the transformed graph that we want to sketch. So let's go ahead and put those in here and move the x-axis down a little bit. So we've got 1, 2, 3, and we need back to negative 4. 1, 2, 3, 4. So there's negative 4, negative 2, that's 1, and that's 3. So let's put our points in. We'll put them in green this time. Negative 2, negative 2, positive 3 is our vertex. Negative 2, positive 3. And negative 4, positive 3 is our focus. So here's our focus. This is our vertex. And we need our directrix. Our directrix is at y equals 0. Sorry, x equals 0, which is right there. So let's label that. That's our x equals 0. And we'll sketch our parabola in here. Through the vertex, opening this way, we could definitely put our focal diameter in there to find some other 2 points in there, but we'll expand upon that another time. And that's it. That's all she wrote. That's what this one looks like. And you see it's the same thing that I have right over here. I even have a focal diameter of 8 listed. We'll talk more about focal diameter next time when we start putting all these together, because we have 2 other conic sections to learn as well. Okay, so let me know what you need help, and I will see you guys hopefully sometime soon.